Good morning, class 9th. I hope everyone is safe at home. I'm Vikas, your physics teacher. In the last video lecture, we completed simple pendulum, part 3 of your first chapter, which has a weightage of 3 marks. Today, we are going to begin with the first part of the first chapter, the chapter Measurement and Experimentation. And today we will discuss few things about measurement. How do we define it? What is the need for measurement? And the physical quantity and the quantity which is used to measure physical quantities, the units, their types, international units, SI, CGS, FPS, and then we will study various types of units, bigger units, smaller units. So let's begin with understanding what is measurement. Measurement is a comparison of a known standard physical quantity with unknown quantity of same nature. Let's take an example. You go to a shop, a fruit seller, and you ask for, say, 5 kilograms of apples. If it's an old-fashioned shop, he may have a physical balance. You know what physical balance looks like. On one side, physical balance has 2 pans, and on one side, he will put in some weights, mass of 1 kg, 2 kg. That is your known physical quantity, which is mass. On the other side, he will put in some apples because he is not sure whether 10 apples would be sufficient for 5 kg. And he will see and he will compare the 2 pans. As they balance out each other, he would give you the apples. So here, those weight are the known physical quantity and the apples are unknown physical quantity. So that's your measurement. I hope that the definition is clear. Now what is the need for measurement? See, the 5 kg apple that you go to one shop and buy it, if you go to another shop, he would also give you the same, number of apples. So what I'm trying to say is, if you go to any shop, you get the same quantity. However, it was not the same long ago. People were using traditional methods like cubit, arm's length. They were using methods of approximation, guesswork, and that led to many arguments, and that used to vary from place to place. So it was not an accurate method, it was also not uniform method of measurement. So the need was felt to devise some kind of method where we have some standard measurements. For that, the units were developed. Now the units comprises of a numerical value, say when I said 5, and then the second thing we need is the unit of same nature, kilograms. Like for instance, if you want to buy mass, you use kilograms, and if you have to buy, say, oil, you may go for a numerical value 5 and the unit liter. Now what are physical quantities? Physical quantities are those quantities which can be measured accurately and conveniently. So these are called physical quantities. length, mass, time, area, volume, speed, density. These are all physical quantities. Physical quantities are of two types. One is fundamental physical quantity. In this we have length, mass, we have time, we have temperature, we have current, we have quantity of substance. You will learn more about this in chemistry. We have luminescence. So we have 2, 4 and 3, 7 fundamental physical quantities. There are 2 more complementary fundamental quantities as well. They are called angle and solid angles. I know you've been measuring them in degrees. However, the SI unit which we'll be discussing is radian for angle, and its solid angle it is steradians. So you should concentrate on these 7 fundamental quantities. These are the symbols by which we technically write them. Now there are derived quantities in addition. Derived physical quantities like area, volume, density, speed, velocity, acceleration, force, many more to come. Now, how do we define them? What are fundamental quantities? Fundamental quantities are those quantities, those physical quantities, which do not depend upon any other physical quantity for their calculation. Like in instance, length. If we have to measure length, we have inch tape. We measured it with the help of inch tape. And we come up with, say, it's 4 meter or it's 10 feet, something like that. So we do it directly. We do not have any other formula. We do not depend upon any other physical quantity for its calculation. As far as derived physical quantities are concerned, these are those physical quantities which depend upon other physical quantities. Other physical quantities may be fundamental quantities or maybe derived physical quantities for their calculation. Like area, we know the formula for area. If we have rectangular shape is length into breadth. In physics, length is again a fundamental quantity. Breadth in physics is also length because it's a distance. It's a length actually that we are measuring. So, area depends upon these 2 fundamental quantities for its calculation. Remember, again as I said to you, length, breadth, height in physics, because it's just a measurement of distance. So in physics we call it length, which is a fundamental quantity. Like volume. Let's have a look at this density, which is mass over volume. Mass is a fundamental quantity. Volume is a derived quantity. So it depends upon its calculation. Next. Now we came up with units. We need to form units in such a way that first it should be universally acceptable. not universally, it should be acceptable because we are living on earth. We may not know whether the people, if living somewhere else, they will accept it or not. They should be uniform, they should be accurate, it should be of convenient size, and they should be easily reproducible. They should not vary with temperature. So these are the requirements that we have from units. Now, the units which are used to measure these fundamental quantities, they are called fundamental units. Like for length we have meter, we can measure length in centimeter, we can measure length in kilometer, then we have kilogram, gram, 1, 2, and so on. Temperature we have Kelvin, Celsius, then we have Fahrenheit, time, seconds, minutes, hour, and so on. All these units which are used to measure fundamental quantities are called fundamental units, and the units which are used to measure derived quantity like meter square for area, centimeter square for area, kilometer square for area are called derived units. We may have for volume meter cube, centimeter cube, then we have liter. Okay? So then we have bigger and smaller units. So these are some prefixes that I have written for you. When I say, you must have heard like kilometer. Now what is the meaning of kilo? Kilo is a prefix. So let's look at some more prefixes. We have, you studied in mathematics as well, deca, hecto, kilo, mega, giga. Like for instance, deca. Deca is 10 raised to the power 1. So if I write 1 deca, then meter, deca is 10 raised to the power 1. After that it's meter, it becomes meter. If I write 1 deca gram, then it becomes 10 power 1 gram. Okay? Similarly, we have hecto, 10 power 2. Kilo, 10 power 3. Like 1 kilometer. 1 kilometer. 10 power 3 meter. 1000. Okay? Similarly, we have for smaller units as well. 1 deci, centi, 10 raised to power minus 1, minus 2, minus 3. So if I write 1 millimeter, this is 10 raised to the power minus 3. Then we have micro, this is a symbol, mu, 10 raised to power minus 6. Then we have nano, 10 raised to power minus 9, and pico, 10 raised to power minus 12. This is something you have to learn. And we just to finish off this video lecture, I just want you to pay attention to this. This is very important, and 1 mark question please would come from this segment. This AU stands from astronomical unit. Astronomical unit. It's a unit of, these are bigger units of length, and 1 astronomical unit is equal to 1.496 into 10 raised to the power 11 meter. It is taken as the average distance of Sun from Earth. 1.496 into 10 raised to the power 11 meter. Then we have 1 light year, 9.46 into 10 raised to the power 15 meter. It is the distance which is travelled by light in 1 year, which is equal to this. Then we have 1 parsec, which is 3.08 into 10 raised to the power 16 meter. It is used to measure the distance of stars because they are even further away from Sun. And 1 parsec is equal to 3.26 light year. Please remember, the average unit if we are told to write the relation between these two in ascending order, descending order, this is the relation. एस्ट्रोनॉमिकल यूनिट की वैल्यू सबसे कम है 10 raised to power 11, फिर 10 raised to power 15 और 10 raised to power 16. आपको ये भी आ सकता है कि 1 parsec और लाइट ईयर का रिलेशन बताइए. 1 mark question minimum is expected from this. So with this I end today's lecture. I hope you learned a lot. Please keep studying. I'll see you soon.